Good afternoon, students.
Good afternoon, sir.
Yeah, can you hear my voice clearly, and can you see the presentation on the screen?
Yes, sir.
Yes, sir.
Yes. Okay, guys, let us start the concept what we're going to discuss today. That is about a conversion of one flip-flop to another flip-flop, or we can call it as a design of one flip-flop from another flip-flop, it is called. Okay. Guys, yesterday I gave you a brief description regarding how we can convert a given flip-flop to other flip-flop. For converting one flip-flop to another one, I told you already, we need truth table of the flip-flops and excitation tables of the flip-flops. In previous classes, when we have discussed about the basics of or working procedure of a flip-flop, we have seen how the truth table is going to function with the circuit what we have regarding the flip-flops. And in last class, we have discussed about excitation tables of each and every flip-flop with the help of truth table. Okay, guys, just try to keep the truth tables and excitation tables of each and every flip-flop with you. Then the design of one flip-flop or conversion of one flip-flop into another flip-flop will be very, very easy in that case. Okay, guys, I'll be explaining a few cases how to convert one flip-flop into another one. Let us see, guys, okay, how you're going to convert the things. Okay. Look at here, guys. I'm going to take the first slide, what we're going to do here, what we're going to see here. So we are doing the conversion of a JK flip-flop into SR flip-flop. Okay, JK flip-flop into SR flip-flop. That is what is our first conversion, guys. Okay, so how to convert JK flip-flop into SR flip-flop? Means JK flip-flop is a basic. That is what you're going to take. And to the inputs of JK flip-flop, we are going to give S and R inputs. That is the meaning, guys. Okay, look at here. JK flip-flop to SR flip-flop means we are going to take JK flip-flops basic block diagram. Then to the inputs of JK flip-flop, J and K, we will give the inputs S and R. That is how we are going to convert JK flip-flop into SR, guys. Okay, guys, to convert one flip-flop to other one, we have very few and very easy steps that we have to follow. Okay, we have very few steps that we have to follow, guys. Okay, guys, keep a book with you. Okay, tell me or do what I'm trying to explain you. Okay, just try to formulate or tabulate whatever the things that I'm explaining on the screen, guys. Okay, that will be very easy and you can easily understand what you're going to do and how we are going to convert one flip-flop to another one. Look at here, guys. To convert one flip-flop to another one, first of all, we have to design a table like this. Okay, this can be called as transition table, or else we can call it a transition table or conversion table we can call. Look at here, guys. Since we are trying to convert a JK flip-flop into SR flip-flop, JK flip-flop into SR flip-flop, we need to take the truth table of SR flip-flop completely. That is what we have to do initially. To convert JK flip-flop into SR flip-flop, we got to take the truth table of SR flip-flop initially. Then you can get these four things. Okay, JK SR flip-flops truth table you can see here. S and R are the inputs. QP and QP plus 1, what they are showing are your present state and next state for the given inputs. From this present state and next state values, okay, from the present state and next state values, we got to get excitation table values, guys. Okay, excitation table values of a JK flip-flop we have to get in here. Okay, so you need to have the truth table of SR flip-flop. We need to have the excitation table of JK flip-flop. That is what we have to keep with us to complete this table, guys. Okay, look at here. Once again, I'm explaining how to fill this table. Since they are asking us to convert JK flip-flop into SR flip-flop, we need to take the truth table of SR flip-flop. We already know how to write the truth table, guys. SR are the inputs. QP and QP plus 1 are your present state and next state. Then you can easily design this truth table by using these two values, present state and next state values what we are having. We need to fill JK flip-flop values, guys. Okay, since we are trying to convert using JK flip-flop, so you need to take JK values, guys. Okay, guys, if you understand, just I will be asking you a simple question. if I am trying to convert, okay, SR flip-flop into JK flip-flop, for example, okay, if I'm trying to convert SR flip-flop into JK flip-flop, which flip-flops truth table I have to take, guys? Which flip-flops truth table I have to take?
JK flip-flops.
Exactly, guys. Then which flip-flops excitation table is needed? Which flip-flops excitation table is needed? SR, clearly, guys.
SR
Okay. Yeah.
flip-flop.
Then we can easily fill this table, guys. Then take the values what you are having under J and what you are having under K by considering S, R, and your present state value QP as input variables. Try to minimize or simplify using K-map. Then get your equations, what you're going to get, guys. Okay, that is what you have to do. Guys, here, the don't care conditions will play a key role in here. Don't care conditions will play key role in here. Okay, guys, I can show this design or conversion part on the screen, okay, which doesn't look maybe comfortable to listen. Just we'll try to convert one flip-flop to other one with an example. Then we'll see remaining all with the presentation. Okay, we'll try to solve one of them, or we'll take this one as example to simplify. We'll take JK flip-flop to SR flip-flop as an example for practice. Then we'll see all on the presentation. Okay, we'll go for a whiteboard and we'll try to simplify that, guys. Okay, let us take that. So what conversion we are taking, guys? What is our first example we have seen?
JK flip-flop to SR.
Okay, JK flip-flop to SR flip-flop we are going to see, guys. This is what we are going to see now. Let us see, let us simplify this one. Okay, see here, guys. I told you already, when you are trying to draw a transition table or a conversion table, when you're going to have JK flip-flop to SR flip-flop, we got to take which truth tables, which flip-flops truth table we need, guys?
SR.
SR. So I'm taking the inputs SR and the present state QN and the next state QN plus 1. Okay. So these are the truth table contents what we need. Okay, truth table contents what we need, guys. So I have taken. And to which flip-flop you are converting? Sorry, from which flip-flop you are converting, guys? We are converting it from JK. So now take J and K inputs in here, guys. Okay. So first of all, let us fill the truth table of SR flip-flop contents. Okay, let us fill the contents. What are the inputs we need to consider, guys?
0, 0.
Yeah, 0, 0 is the first combination with present state 0 and present state 1, guys. That is my first condition. Okay, then let us go for the next input condition, guys. What is that?
0, 1.
0, 1.
Yeah, I'm taking that 0, 1 with my present state 0 and 1 is to be tested. Then let us go for the next condition, guys. Next
1,
input
0.
condition. Yeah, I'm taking that
1, 0.
1, 0 and 1, 0.
1, 0.
With my present state values as 0 and 1 is my next condition, guys. That is what I have taken. And last condition, last input condition, that is 1, 1 with my present state and the present state values as 0 and 1. Okay, so I have finished my input conditions, guys. Since it is a sequential circuit, to get my next state or output, always we need present state, present inputs, and also present state completely. Unless otherwise, it is very difficult, guys. Okay. Now you have to say this to me, guys. What are your next state values? Qn plus 1. When 0, 0 is taken with your present state 0, what is my next state?
0, sir. 0.
Yeah. What about this condition? 0, 0 with the present
1.
state 1. Yeah. Then when I'm taking 0, 1 input condition with my present state 0, what is my next state?
0.
0, sir.
Yeah. What about this condition now?
0,
0, sir.
Yeah. Then I'm taking 1, 0 input condition with present state 0 and 1. What will be my next states?
1,
1,
1, 1, sir.
Yeah, 1, 1.
1.
Then What about the last condition we have with inputs 1 and 1?
Indeterminate state, sir.
Don't care, sir.
Yeah, don't
care
care. We should not say indeterminate. Okay, always it is indeterminate, but we should say output is don't care condition. Okay. Now, guys, you have to shift to excitation table now. Excitation table. Go to the excitation table of JK flip-flop now. Go to the excitation table of JK flip-flop now. Have you opened it? Have you kept it before you?
Yes, sir.
Yeah, now look at there.
Yes, sir.
If your present state values of present state and next state values are 0, 0, then what will be your J and K values?
0 and don't care, sir.
Don't care,
Yeah,
sir.
I'm noting it down from your information. Then if my present state and next state values are 1 and 1, what will be my J and K values?
Don't care and
care
zero.
and zero.
Yeah, don't care and 0. So I'm writing don't care and 0. Then go for the next condition, guys. With 0, 0 again, 0, don't care. Okay. And with 1, 0, what is the condition, guys?
Don't care and one, sir.
One care and one, sir.
Yeah, don't care and 1, I'm taking it. Then 0, 1.
1 and don't care, sir.
Yeah, 1 and don't care. Then 1 and 1 again, don't care, 0, I think so. Isn't it?
Don't care and zero, sir.
Yeah. Then, guys, I'm having 0, don't care, and 1 and don't care, guys. Do we have any conditions like that? Do we have any condition like that in the excitation table? Like
No,
0, we have
No,
0,
sir.
1,
Sir.
we have 0, 1, or we have 0, 0, and we have 1, 0, and we have 1, 1, but we don't have don't cares in the excitation table, guys. Okay. So what we will do, we'll take these 4 conditions like don't care. Okay. Since we don't know what to consider, we'll consider J and K, both the values as don't cares in here. Okay. That is the thing we have to do. Nothing else. There is no other go. We have to take don't care, guys. Okay. That is what we can do here. Okay. Now, after finishing this conversion table, now we need to shift to K-map simplification, guys. Okay. Now we need to shift to K-map simplification. And since we have 2 inputs and a single present state, we have 3 input variables such that we need to go for a 3 variable K-map, guys. And also we have totally 8 conditions, isn't it? Totally 8 conditions are available from 0 to 7, like so that we can only choose a 3 variable K-map. There is no need to go for a 4 variable K-map. So let us go for a 3 variable K-map to find your outputs J and K. To find your outputs J and K, let us find what is the value of J now. Okay, let us find what is the value of J we can get. So guys, tell me how many cells you will have in a 3 variable K-map?
8, sir.
8.
Yeah. So yeah, let us take the values, input variables S, R, and Q, N, or else I will take Q simply. Okay. S, R, Q I'm showing, guys. Guys, tell me if I am trying to find what is the value of J now. Okay. So what values I have to take now into the K-map? If I am trying to find what is my value of J, what values I have to take into the K-map? Which values I have to take into the K-map for finding the value of J or equation for J? In this transition or conversion table, which values I have to take into the K-map for finding the expression for J?
SR and Q.
Yeah, input variables I have taken, guys. These are the input variables. So SR and Qn is taken. Now we have totally 8 cells to fill. Which values or data is to be considered or to be taken to fill this K-map to find the value of J? To find the value of J. Which values I have to take? Guys, this is a
J values, sir.
yeah. Since we are trying to find the values of J, or we are trying to find the output J, we will consider value of J. That is common, guys. We have done same thing in K-map simplification also. From truth table to the K-map mapping, we have done that one also in previous classes. We'll take the same things, guys. Tell me. So what values you have to take? You have to take the values under J here. So I'm taking 0. What is next value?
Don't care condition.
Yeah. Third one is
0.
Yeah,
Zero,
next
sir.
one.
Don't care.
Don't care.
Don't
Yeah.
care.
Then,
One.
One.
then,
Don't care
Don't care.
condition.
yeah,
Don't care.
again, don't care, again,
Don't.
and don't care. Okay, I have conditions like this, guys. Okay, I have conditions like this. Okay, so you can simplify like this, guys. You can simplify like this. You can have a quad in here. You can have a quad in here. Okay, or else we'll do one thing, guys. Instead of considering all these things, okay, so let us group these things. Since we'll group once, look at here. These three were don't cares, guys. These three were don't cares. We already know that taking the value of don't care is a designer's wish. According to our wish, we can take any value in the place of don't care. Either we can take 1 or 0. Okay, either we can take 0 in the place of don't cares, or else we can take ones in the place of don't cares. Since I have 1 in here, if I take ones in the place of these three don't cares, okay, if I consider these three as ones, so I can directly get my value in here, guys. I can get my values in here, okay. So or else is there any other possibility, guys, to group the things? There is no other possibility, okay. So the only thing I can do is, okay, so guys, I have done a small thing here. So on this side only we can take one variable. Just you also haven't corrected me. So on this side only we can take single variable. Na? I will take S here, okay, and I will take two variables this side. I forgot R and Q here, okay. Normal 3 variable map. I can take only one variable here and 2 variables here. Look at here, guys. So I'm having a 1 in here. I have 3 more don't cares here. We already know that taking the value of don't care either as a 0 or 1 is our wish. So I'm trying to take this as 1, this don't care as 1, and this don't care as 1. So I can make this as a single quad in here, okay. Guys, if I make this 4 elements as a quad, if I make these 4 cells as a quad, what will be your value? J is equal to, tell me the value of this quad. Tell me the value of this quad, guys.
Yes, sir.
Yeah, S. Exactly, guys. So you got the value J is equal to S. Okay, J is equal to S. Like that, we need to go for another K-map, guys, to find the value of K now. To find the value of K, then take a 3 variable K-map, same, with the same 3 input variables we have. So let us take the 8 cells what we have in here, and let us map the values under K into this K-map, okay, and let us find what you're going to get. Take your first input variable, S, and take 2 other input variables, R and Qn, into this side. Now tell me, guys, take these values, okay, which are under K into the K-map. Tell me what values you are having in there. So I have don't care initially.
Don't care.
Then
0.
Yeah.
Don't care.
Then
1.
1.
1.
Okay. Don't care.
Don't care.
0.
0.
Yeah. What I have else? What I can take,
Don't
guys?
care.
Don't care and don't care. Okay. These are the values. Look at here, guys. I have a 1 in here, and to group this one, if I take these 3 things as ones, okay. I told you several times, guys. I'm repeating once again. In the place of don't cares, either you can take 0 or 1, but which suits us? If you take these 3 as zeros, we cannot make any quad, or we cannot simplify this one. Simply I can make this as a single element, and you will get all the variables into it. Simplification will not happen. So I am trying to take these 3 things as ones, and if I consider all 3 as ones, I can make this as a quad in here. So guys, tell me, if I take that as a quad, what will be the value of K here? What will be the value we'll get here? Look at here, guys. I have S in this line, S bar in this line. I have S in this line. So S and S bar will get cancelled. So consider about these 2 columns now. In these 2 columns, what will be common? So you will have RQ and RQ bar. So your K will be equal to R. Okay. So you got J equal to S and K equal to R here, guys. Okay, you got J equal to S and K equal to R. Now, let us go for design of the given JK flip-flop. Okay, given JK flip-flop with the help of SR. Look at here, guys. This is also important. You may get confused how to design. So, what is your question, guys? Convert, okay, convert JK flip-flop into SR. They are asking to convert JK flip-flop into SR. So, initially you are having JK flip-flop. So, take the two inputs what you are having initially. So, you consider the two inputs what you have initially, that is J and K. Okay, look at here, guys. Since we are converting JK flip-flop into SR, you consider initially the JK flip-flop. So the two inputs are J and K, and the two outputs are Q and Q bar are your outputs, guys. Okay, Q and Q bar. Now, since you are trying to convert JK into SR, we need to give the connections. Okay, J to the what value you got, and to the K what value you got in the K maps. What value you got in the place of J, guys? What value you got in the place of J?
Yes, sir.
Yes, sir.
So you consider S in here. What value you got in the place of K, guys?
R, sir.
R,
Ah,
sir.
so I'm giving the two inputs, and this clock is mandatory. Don't forget for any flip-flop. Clock is always mandatory. Okay, write it as CLK. This is nothing but a conversion of JK flip-flop into SR flip-flop. Very important in examination point of view also. So they have asked questions on these conversions, but they may ask any conversion, guys. Not only JK to SR, SR to JK, D to T, JK to T, T to JK. They can ask any conversion, guys. This is how you need to convert the one flip-flop into another flip-flop. Guys, do you have any doubt in this procedure of converting the given JK flip-flop into SR flip-flop? Any doubts in this one, guys? Any doubts in this one? Any doubts in this procedure, what we have followed so far in the conversion of JK flip-flop into SR flip-flop? Guys, in a quick session, let me explain you what are the steps that we have followed in the conversion. Initially, I have taken, since I have seen JK to SR conversion, they have asked, you consider SR flip-flops truth table. SR are the inputs, QN is your present state, QN plus 1 is your next state. So write the complete truth table of SR flip-flop. And you consider from which you are trying to convert. Since they are asking to convert JK, so take the input variables of your JK flip-flop. From the present state and next state values, what you are having in the truth table, you take the excitation table and fill the contents in here. Okay, then you will get J and K values. And take a K map. Since you have 8 variables, consider a 3 variable K map for J and K. Get the values what you are getting. Okay, for each and every flip-flop you will not get the same equations, guys. Okay, J equal to S and K equal to R, you will not get something like that. You may get equations also. You have to design that equation and you have to give the connections to that J and K. For example, guys, if I'm not getting S here, for example, if I'm getting S plus something like Q bar into R, something like that, if I'm getting, for example, I'm saying, guys, you need to design a S input, Q and Q bar input, R input is to be taken, and we have to connect, design this logic, and we have to give that connection to J here. Similarly, we have to give that connection to K here. We'll show that, we'll see those examples in the next classes, guys, or next conversions. For now, we got very simple conversion that you got J is equal to S and K equal to R by the K map simplification. So I have taken JK flip-flop initially and given the values what I have to give for J and K in here, okay, available in here to the K map, guys. Okay, guys, any doubts still? I will explain that. Any doubts in this procedure? Very, very important questions, guys. In the internal exams or external exams, these kind of questions have repeated several times. Any doubts in this conversion process, guys? Same procedure you have to follow for each and every conversion. Same procedure. Based on the conversion they have asked, you need to write the truth table of the given flip-flop, and you have to take the excitation table from which you are trying to convert. Then take the K-map simplification, get the equations and give the connections to the K-maps what you got. Any doubts in this conversion, guys? You can ask me now.
Sir.
Yeah.
Sir, first column lo don't care naga sir. I will group change kar sir.
Even these two things. Are you asking about these two things, guys?
Sir.
Yeah, look at here, guys. Sudhir.
Yeah, sir.
If I make this as a which one? These four you're asking, or these two you're asking? Sudeep, listen. First of all, I will clarify the doubt of Sudeep. Look at, I have one in here. Since we will map only once, since we will only group once, I have a single one in here. And that's why to group this one for a simplified answer, I consider these three things as ones. Okay. Since I have one in here, since I want to group one with a simplified answer, I made a quad by considering these three things as ones. So I got J equal to S. If I consider these four things as ones, I can get an equation like this. Okay, but ee nalgu aithe group avutayandi. But what about this one? Again, you have to make these two things as a group, or you have to make these four as a group. Your complexity in the circuit will increase. Or else Sudeep is asking to group these two things. Listen, Sudeep, what is the need of grouping these two things? Is there any one is associated with these two don't cares? Is there any one is associated with these two don't cares? Ee rendinti pakkana edanna one unda?
No, sir.
No. If I don't want to group one anywhere nearer to this one, why should I consider that these two as ones? Ee rendinti one ga endu consider cheyali? I will take as zeros. No problem for me. According to my wish, I want a simplified answer actually. So in the case, if I consider these two things as one, if you do one anukondi, S plus something else you will get here. S plus you will get something here. Ala raayakudante raayichandi. You can take those values also. But I told you one concept, a concept called essential prime implicants and prime implicants. In this K-map, this S is essential prime implicant, but not these two ones. If rendu kalipite vache group anedi essential prime implicant kaadandi. That is a prime implicant, that's it. Ikkada naaku okavela ikkada one undi leka ikkada one unte, I can group these two things, or I can group these two things. Ala em ledhu kabatti there is no chance, or there is no need of taking these two things as ones and grouping it. Ee rendini one anukoni nenu group cheyalsina avasarame ledandi. Okay na? I can directly consider these two things as zeros and can remove it. Ikkadaithe kachithanga one undi kabatti deeniki simplified answer ela vastundante by considering these three don't cares as ones. If I make a quad, I can get simplified answer like J equal to S. Then some other girl has asked some doubt whether it is clarified, or do you want to ask that question? Ask me.
Yes, sir. Clarified, sir. Same doubt, sir.
Okay. Sudeep, are you okay? Do you got the answer? What you expected?
Yeah, sir.
Okay. Chudana, oka simple concept. Meer ikkada group cheyalsina one. Since I have one in here, to simplify this, I will consider these three don't cares as ones. ఒకవేళ నేను దీని మాత్రమే అనుకుని ఇవి రెండు పెయిర్ చేయొచ్చండి. బట్ దేర్ ఇస్ ఎ ప్రాబ్లమ్ దట్ బై పెయిరింగ్ యూ విల్ నాట్ గెట్ ఎ సింగిల్ ఎలిమెంట్, యూ విల్ గెట్ సంథింగ్ ఎల్స్ లైక్ 2 elements or 3 elements will come into this. ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ మేక్ దీస్ టూ థింగ్స్ యాజ్ ఎ గ్రూప్, ఇవి రెండింటిని వదిలేసి ఇది మాత్రమే వన్ అనుకుని ఇది పెయిర్ చేశాను అనుకోండి, ఐ విల్ గెట్ ఎస్ బార్ ఇంటూ మేబీ ఎస్ బార్ ఇంటూ ఆర్ బార్ యూ విల్ గెట్. ఆర్ యూ గెటింగ్ ఎస్ హియర్ ఏ సింగిల్ ఎలిమెంట్? ఇవి 4 గ్రూప్ చేయడం వల్ల నాకు ఎస్ వచ్చిందండి. If I make these two things as a pair, I will get S bar into R bar. Which one is very simple to look? Which one is very simple to design even? J equal to S. So by making a quad, I can remove 2 elements. I can get a single thing. But I make a pair, I will get 2 elements. So complexity in the design of your circuit will increase. So I have considered these 3 things as ones. You don't care about the 0 తీసుకునేది 1 తీసుకునేది మన ఇష్టం అండి. But guys, for conversion or some of the pre-designed circuits are there, like conversions, or else we have something like code converters. In all those things, designers already given some benchmarks to to consider which one has 0, which one has 1 from your don't cares. So we have to follow that. Definitely we have to follow that. You can ask me, sir, why should I consider only these two things? ఇవి రెండు మాత్రమే నేను కన్సిడర్ చేస్తాను లేదా ఇవి రెండు మాత్రమే కన్సిడర్ చేస్తాను ఇవి రెండు కూడా నేను 1 గా కన్సిడర్ చేస్తాను యు హావ్ టోల్డ్ మీ డోంట్ కేర్ అనేది మనం 0 గా తీసుకోవచ్చు 1 గా తీసుకోవచ్చు అన్నారు కదా why you are saying me now to take only zeros not ones you can consider guys that is your wish okay don't care taking 0 or 1 in the place of don't care is completely your choice but you have to consider the don't cares which will give you a simplified answer and perfect answer. That is what you have to consider. Otherwise, you can consider any don't care as 0 or 1 according to your wish, designer's wish. Okay, guys, any doubts still in this conversion process? Any doubts still, guys?
No,
yeah. Then let us go and see the remaining conversions what we have, guys. Okay, so from the PPT, we will see all those things. So far we have seen JK to SR conversion. We are going to the same kind of procedure to convert one flip-flop into another flip-flop. Look at here, guys. Next conversion is SR to D flip-flop. Look at here, initially since we are converting SR into D flip-flop, you consider the D flip-flop's truth table. Since I have D as a single input, you consider 4 combinations. 0, 0, 0, 1, 1, 0, and 1, 1 in the place of your input and present state, guys. And you already know that D flip-flop is nothing but a data flip-flop or delay flip-flop. Whatever the input you are giving will be directly taken at your output. Whatever the input you are giving can be directly seen at your output. 0, 0, 1, 1 is available in the input. Same 0, 0, 1, 1 you can see at your output, guys. Okay. So by considering this present state value and next state value 0, 0, 1, 0, 0, 1 and 1, 1, you take the excitation table of SR flip-flop, you take the values from them. Okay. So you need to design a K-map for S and for R here. Since I have only 4 cells here, you consider